So today we're going to be talking about an introduction to moles, just kind of reviewing some of the things that we've discussed in class, and then we're also going to jump into how to do one-step mole conversions. So let's get started. The first thing I want to talk about is some vocabulary that we've discussed. The first thing that we talked about was atomic mass. Atomic mass is the mass of a single atom. So for example, if you were to talk about oxygen, one oxygen atom would have an atomic mass of 16 AMU, which stands for atomic mass unit. And you'd find that value on your periodic table. Then we talked about molecular mass, which is the mass of a single covalent molecule or covalently bonded molecule. An example of that would be something like a water molecule, H2O. There are two hydrogens. Each hydrogen has a atomic mass of 1.01. So you multiply that times 2, and then you add that to the atomic mass of a single oxygen atom, and you end up with a total of 18.02 AMU for one single covalently bonded molecule. Separate from that is the formula mass, very similar to molecular mass. The only difference is that it refers to an ionic compound, the mass of a single ionic compound. For example, if you have magnesium oxide with a formula mass of 40.31. That is the way we find that is we find the atomic mass of one magnesium atom, 24.31 AMU, plus the mass of one oxygen atom, which is 16 AMU, and you add those two things together and you get the formula mass of the ionic compound. All of these things kind of lead us to the main idea, which is molar mass. Molar mass is the mass of 1 mole of any substance. We use the same term to describe 1 mole of an atom, such as oxygen. If I have 1 mole of an atom, instead of using AMU as the unit for the mass, we're just going to change it to grams per mole. So if I have a mole of oxygen atoms, I have 16 grams, and that means I have 1 mole. So 16 grams per mole is usually the way we would say that. And a mole of water molecules, if we were to talk about the single covalent molecule, we'd use molecular mass. If we're going to talk about a mole of water, I have 18.02 grams per mole. And then finally, instead of using a different word for formula mass when we talk about one single ionic compound, we are going to talk about it, we're just going to call it molar mass. If I have 1 mole of magnesium oxide, I have 40.31 grams per mole. Sorry about the little typo there. It should just be grams per mole, not 2 G's. So the next thing I want to cover is, what is a mole? So a mole is to 6.02 times 10 to the 23rd, as a dozen is to 12. So a mole is just a way to group molecules together in a way that is more helpful for us when we actually talk about them. Because atoms are so tiny that it does us no good to talk about one single atom. We talk about large groups of atoms. And what's the point of talking about a single donut when you could talk about a dozen, right? So 1 mole is equal to 6.02 times 10 to the 23rd particles, okay? We can write that in a couple different ways. If we are going to be doing unit conversions, we want to write them as such, where we have 1 mole over 6.02 times 10 to the 23rd particles, or you can take the inverse of that, and we're going to use that to help us set up unit conversions. So if I wanted to convert 2 moles of a substance into the number of molecules, I want to first circle what I'm solving for, the units that I'm solving for, and I want to underline what I am given. So I'm given 2 moles and I'm solving for molecules. So I'm going to set it up so that I have 2 moles over 1 just to get me started, and then I'm going to multiply it by one of the 2 factors that we see written above. And we know that our goal is to cancel out the units of moles. So we have to have moles kitty-corner from each other in the calculation. So I'm going to end up setting it up just like this. We're 2 moles on the top, And then on the bottom of the next term, we have 1 mole so that we can divide away or cancel out those 2 terms of moles. And then on top of that, our goal is to convert that into molecules or particles. And the way that we're going to do that is just, we know the fact that 1 mole is equal to 6.02 times 10 to the third particles or molecules. So that way, once we've divided away the moles, we know all we're left with is particles or molecules. Those words are interchangeable. And then when you plug that in your calculator, you just multiply everything across the top. 2 times 6.02 times 10 to the 23rd particles, and then you would divide it by the denominator multiplied across. Well, 1 times 1 is 1, so we don't really have a lot of multiplication to do on the bottom. We just know that our answer is going to be as is. At this point, you can go ahead and take out your packet and turn to page 10. We're going to take a look at that for a moment and do a couple of little notes. So what we just talked about was how the mole relates to number of particles. And this would be one of our chemistry factors. So similar to what you just saw on the last slide, I'd like you to copy down on page 10 in your packet the moles and particles conversion factors. You have 1 mole equals 6.02 times 10 to the 23rd particles, or you can put 6.02 times 10 to the 23rd particles on the top and 1 mole on the bottom. It depends on which way you're converting. If you start in particles, you're going to use the one on the left. If you start in moles, you're going to use the one on the right, because that's going to allow you to cancel out your units. So the other thing that you should make note of is that if you're talking about particles, you could be talking about atoms, you can be talking about molecules, anything that's a smaller part. Okay? Then we have another way to talk about chemistry factors, another way to relate moles to something, and that's going to be moles related to mass. So whenever you're trying to relate moles and mass to each other, you have 2 options for conversions, and they're just the inverse of each other, the same way that moles and particles were. So if you take a look, moles and mass, you can have 1 mole is equal to the molar mass in grams. So what that means is 1 mole of a substance equals the atomic mass of that substance with the unit of grams. So I know that 1 mole of lithium is going to equal 6.94 grams. So that kind of came from the Intro to Moles ChemQuest. And we just turned that into a chemistry factor because we know that 1 mole is equal to molar mass in grams of any substance, whereas molar mass in grams is equal to 1 mole. So we can kind of flip-flop those and make them into factors. It's a little confusing when I write in molar mass G though, so I gave you an example down to the right. It says for every 1 mole of oxygen gas, O2, I have 32 grams of oxygen gas. I know that the atomic mass of oxygen is 16.00 AMU. So I first of all have 2 oxygens, and then those 2 oxygens, if I multiply the atomic mass of that, I'll get 32 AMU. That's for a single molecule. Now, if I want to look at a mole of those molecules, I can just switch out the grams and AMU units. So now when I say I have 32 grams of oxygen gas, I know that I have 1 mole of oxygen gas. And then you can also take the inverse of that as well. The next thing that we're going to do is take a look at page 11. So what we're going to do is 2 example problems. We're going to do number 2 and we're going to do number 3. So the first thing we have to do is go ahead and underline the given value. It says how many grams of copper are there in a 2.35 mole sample. So I'm going to underline 2.35 mole sample because that's our given value. And then I'm going to circle grams of copper. So my memory trigger is that this is underlined. So with my 2.35 moles, I'm going to start with that and I'm going to put it over 1. 2.35, and I always want to put moles of copper. MOL is just a shorthand way to write moles. So we put that over 1 just to kind of help us visualize. Then we're going to multiply by one of our chemistry factors. I'm going to try to move my face here so you can see all the factors. So when you take a look at this, the first thing you need to notice is I have moles here, so I know I want to have moles at the bottom here as well. And I know that I want to convert into grams. And there is a way to convert from grams to moles. And I'm going from moles of copper to grams of copper. So I've got the blue and I've got the red. The blue converts moles and particles. I don't want particles. I want moles in mass or moles in grams. So I'm going to take a look at my two factors. I've got 1 mole over molar mass in grams, or I've got molar mass in grams over 1 mole. So I know that I want to cancel out my moles, which I will do because I'm going to divide those away. So I must want to use this factor. So I'm going to put 1 mole on the bottom, and then I have to know what the molar mass of copper is in order to convert this. So conveniently, I took a look at my periodic table and I found that the molar mass of copper is 63.55 grams. Then I went ahead and calculated. I just multiplied everything across the top and I got 149.3425 grams. Now, the tricky thing here is the sig figs. Is it really that tricky though? You can decide. But I've got 3 sig figs in my value here. You do not include the sig figs of the grams of copper, so my answer should be 149 grams of copper. Then I want to go ahead and take a look at the next example, calculate the number of water molecules in a test tube. So I want to take my given value and put it over 1, and I want to solve for water molecules. So my given value, 0.488 moles of H2O over 1. And I want to compare moles or convert from moles to particles. So I know moles has to go on the bottom, and I know particles has to go on the top. In this case, we're using molecules. H2O, moles of H2O. And I know that in every 1 mole, there are 6.02 times 10 to the 23rd molecules of water in 1 mole. Again, I'm going to multiply across the top, and my answer comes out to be, from my calculator, I get 2.93776 times 10 to the 23rd molecules H2O. Again, if you're going to do the sig figs, this has 3 significant figures in it, so our answer should have 3 significant figures. This 7 is going to round our 3 up to a 4, so we end up with 2.94 times 10 to the 23rd molecules of water. And that's how you do a one-step mole conversion. So tomorrow we're going to go ahead and do a bunch of practice, and hopefully by the end of the day you're going to be a pro. Thanks for watching.